In this exercise, we're going to practice application of visualizing statistical relationship and distributions using Seaborn. Here we're loading a dataset called insurance dataset. This dataset includes insurance charges for different patients, and we've got a couple of variables indicating patients' demographics. We would like to explore the relationship across these variables. Very often, a good starting point in any exploratory analysis is to do pair plot. Pair plot basically creates a combo of a scatter plot matrix and histograms for all of the various variables in the dataset. So this is very handy because we can just in one command, which is pair plot, create all of these visualizations. So I'm going to pass in data to pair plot, and this is going to create that pair plot. So for each pair of variables, we've got actually here scatter plot matrix. For example, you can see the relationship between age and charges. So you can see overall that charges increase per age, but it's as if we've got three categories. There are three groups with three different trends, right? So my guess in here is that it probably depends on the region. So each region has a different baseline, but the relationship, the trend is consistent across regions. For example, look at BMI, for example. There is much more noise here and there, but it's probably two groups and probably depends on the person being smoker or not. Some of the relationship are completely noisy. So for example, here, if you look at age and children, it doesn't look like there is a relationship between age and children here, which probably makes sense. We also see the histogram. So you can see that you've got a histogram. So you can see that most of the patients are almost equally distributed across age. But if it look at BMI, there is a concentration of BMIs around 30 something. That's probably slightly overweight or overweight maybe, with kind of a normal, bell-shaped curve here. When it comes to children, you see that most of the patients here have no children or one child, and it goes down from here on. So this pair plot shows a couple of things in one visualization, which makes it very useful for starting to understand the data here. Now, we're going to improve on the pair plot using pair grid. That's to customize it a bit. We need to make the upper half showing the histogram plot, and we're going to use kdePlot to show the lower half. Okay. So let's take a look at doing it with pair grid. The process here is to first start by creating the pair grid. So I'm going to do pair grid of data. That's by default is going to create an empty pair grid that we want to populate. So let's populate it using the instructions here. We're going to populate the upper half using histogram plot. So I'm going to use the function map upper, and I'm going to use histogram plot here for the upper part of the pair grid. That's going to create histogram plot in the upper part, but because the upper part is pairs of variables, we're going to see heat maps. That's going to show us the concentration of these values here across the upper part. And it's up to us to customize it the way we want. We can create a scatter plot in the upper part if that's what we want to do. We will stick with the specification of the problem here, but you can see the flexibility in here. The lower part has to be kdePlot as specified in here, with filling equals to true. So I'm going to do g.map lower here, and I'm going to do kdePlot. And that's going to give us a kdePlot. And I did not specify filling in here, so you can see we've got the contours. But if we set fill equals to true, that's going to fill those contours here, and you've got kind of a nice gradient color shape here showing the concentration of the data. All right, excellent. So now let's finalize with the diagonal. The diagonal is saying do a histogram. So g.map diagonal here is going to be histogram plot. And it's also set to make KDE true. So you're going to get not only a histogram, but we're going to get also a kernel density estimation line on top of the histogram. So you can see that we condensed a lot of information here in one plot. And this command, the pair grid, allows us to create a nice visualization to set up the stage for either a report on the data or for our use in exploring the data set. Now next, let's focus on charges and BMI. The question here that we want to explore whether charges depend on the BMI and whether this dependence relates to the person being a smoker. We actually kind of hypothesize this relationship here. Is kind of, you see the two blobs here, so maybe one blob belongs to smoker and one blob belongs to another smoker. And if we separate them to do two blobs, maybe there is a relationship across one of the blobs. So here we can use a relation plot or a joint plot. A joint plot is kind of will give us also a combination of different plots. Let's start with a relation plot here. Actually, because we're looking for distribution, it's not strictly speaking a relation plot, so it's a distribution plot here. So here data is equal to data, and we want to look at x being the BMI and y being the charges here. So by default, this is going to give us this kind of a heat map, but I want to switch it to a kernel density estimation plot. So kind equal to KDE is going to give us this contour here, right? Now my next step is to include smoker by leveraging the color channel. So I'm going to map hue to smoker here. And this is going to give us two overlaying the kind of a blobs. And this kind of confirms our initial hypothesis that, for smoker, there is kind of a relationship, strong relationship between BMI and charges, right? So smoker is one kind of contributing factor to increase charges, or maybe vice versa. Weight, obesity adds on top of smoking in terms of worsening conditions, leading to more medical charges. So those two factors, are indicators for worse outcomes, health outcomes, if charges, strictly speaking, are associated with outcomes that require more healthcare, which is generally the case. If you look at non-smokers, the relationship is not so clear. It seems that more or less you've got equal distribution here, so maybe BMI is not a big factor. Maybe it's a bit kind of a linear, but it's not as steeply sloped as the one for smokers. We can turn joint plot as the question asks, and this is going to give us on top of this also KDE is kind of for the univariate and also the bivariate distribution here. Okay, so let's take a look at last question. Actually, we've answered the last question. Or not yet. The question is asking us to look at differences across sex, not across smokers here. So we can actually look at sex. We can leverage yet another channel here. So if we go back to the kdePlot here, we can map a column here to sex, and this is gonna give us two facets per columns for female and male. So you can see that the relationship here doesn't really depend on sex a lot, right? We see the same trend across female and male. For smokers, BMI worsens conditions, or vice versa. For obese people, smoking worsen conditions. And that's the same relationship holds for both female and male patients. So you can see that in this exercise, we managed to really uncover a lot about this data. using the basic relation and distribution plots.